Hi fellas, this is Chemaddicts again to the solution. Welcome back to another video tutorial. Well fellas, now today we're gonna solve a problem related to mechanics. So the topic for today is projectile. So let's read, let's start. Okay. So in this video tutorial we're gonna solve the second part of this question. So if you have missed the previous part, don't need to worry. Sorry fellas, oops, I'm gonna put the solution of previous question at the end of this video tutorial. Well fellas, okay. So today we're gonna solve the second part of this question. So if you have missed, don't worry. I'm gonna put the link to the previous episode at the end of this video. Okay, at the end of this video. Oh, no. At the end of this video. Okay. So let's read the question. The question says, find the direction of motion of P when it passes through the point on the path where x equals to 20. Okay. So here we need to find the direction of motion of P when it passes through the point on the path where x equals to 20. So how am I supposed to find the direction of motion of P? How is it possible? Is it upward, downward, or which direction? North, south, east, west? We don't know. So here the direction of motion means here is the angle. Okay, so the angle at which this is at. Okay, so the angle at which the motion the particle P is at. Okay, at that moment, at that particular moment. So the angle at which the particle P is at that particular moment is called the direction of motion of P. Okay, so this actually meant here is angle. That's it, nothing complicated. So let's name this angle as alpha. Okay, alpha. Okay, so find the direction of motion of P when it passes through the point on the path where x equals to 20. Okay, so before we have derived this equation. So this is the equation for vertical position vector. Okay, so this is the equation for vertical position vector. Since here in this question it has said that the position vector for the path of P is this. Okay, so here we can see that the vertical component of P, which is the vertical component of J, or vertical component J, has this thing Y. So since the vertical component of position vector is Y over here, as we can see, so this should be the vertical position vector, the vertical component of position vector. That's it, we have found. So here let's find the direction of motion of P. Okay, so at first let us interpret this on the previous diagram that we have drawn before. So this is the diagram that we have drawn in the previous video tutorial. Hey, don't worry, I'm gonna put the link to the previous video at the end of this video tutorial. So for now, just have a look. Okay, so here everything is here, you don't need to worry. So here this is the initial velocity over here. So initial velocity is given, the position vector is also already given, x, I, y, j. Okay, so now we have also derived the equation before. So in here what we gonna look at is the position vector. The question meant here is the position vector of a particular time. Suppose this is the position vector Suppose the particle was here, okay, at this time, where when the horizontal component is 20. It is already given in the question. If you look here, this is the horizontal component of position vector, horizontal component, okay. So the horizontal component is given here. So now let us substitute the value of x over here. Then we're gonna find a vertical position vector. Oh, we wanna find vertical position vector, right? Aren't we supposed to find the angle? Yeah. So let's see how we gonna find the angle. So our main objective is to find the angle by anyhow. So now let's have a look. So in here, let us rewrite the equation once again. So the equation was y is equals to root 3x minus gx squared divided by 98. Okay. So this was the previous equation. Okay, this is the equation that we have found earlier. So y is equals to root 3x minus g by, this is g, by the way, this is g, okay, g x squared by 98. Well, we have found. So what we gonna do is, at first let us differentiate this with respect to x. Okay, so why we gonna differentiate? That's because if we differentiate, that would coincide with the gradient. So we already know that the gradient from mathematics, from trigonometry, is gradient is equivalent to tan alpha, and from that we are able to find the angle. Okay, so we already know from the graph. Okay, suppose this is the graph. So suppose this is 2 points. Okay, so here suppose this is x2 y2 and this is x1 y1. Okay, so here the gradient is, we already know from the previous concept, y2 minus y1 divided by x2 minus x1. Okay, so y2 minus y1 divided by x2 minus x1. So this gradient, since if we try to find the angle, okay, this is opposite by adjacent. So we already know that tan alpha, we have already named it as tan alpha, so we can't name it as theta. Okay, so tan alpha is what, y2 minus y1 divided by x2 minus x1, so which is, in other words, is gradient. So that is why we are finding the dy by dx, since this also means the change in y divided by change in x. So I hope that you get it clear. I hope that you have understood by this meantime. By this meantime you have understood that why we are able to differentiate this thing. So let's just differentiate. Dy by dx is equivalent. So if we differentiate root 3x, we're gonna end up root 3 minus, if we differentiate this thing, we're gonna end up getting 2gx divided by 98. Yahoo! Sorry Google, just kidding. So now let us substitute the value x equals to 20. Okay, so from the previous from the question over here, the value of x is given here is 20, which is the horizontal component of position vector. Okay, horizontal component of position vector here is 20. Since the horizontal component of position vector the horizontal component of position vector here is 20, so we're gonna substitute this value 20. So here dy by dx is equals to root 3 minus 2g 20 divided by 98. So we will be end up getting root 3 minus 40 g divided by 98. Okay, so isn't it little bit complicated? No, it isn't complicated, it is simple mathematics. Okay, don't worry. So in here we also know that dy by dx is also equivalent to this thing, this guy over here. Since this guy is equivalent to this guy, it is the same dude. Okay, so we can also write tan alpha is equals to root 3 minus 40 divided by 98 g. So if we calculate this angle by tan inverse this root 3 minus 40 g divided by 98, so we will be end up getting minus 66.2 degree. Okay, so this is, since this is negative, okay, so it is the angle negative over here. Okay, so this is the negative angle, so it is downward. So in here, since it is below the horizontal line, okay, over here, since it is below the horizontal line, we can also write in other words as this 66.2 degree below the horizontal line. Okay, so that's it. That is the answer, which is alpha is equals to minus 66.2 degree. In here, by this meantime, we already know that in here they have asked us to find the angle. Okay, so they just wanted us to find the angle. That's it, nothing complicated. So fellas, that's the end of this tutorial. I don't want to make this tutorial any longer, because you always mind why my video tutorial is really long, not wrong, long. Why my video tutorial is really wrong, really long. Is it right? Really long. Why my video tutorial is really long? Okay, is really lengthy. That's because we always try to discuss in details about this concept. Okay, since most of the student might, most of the sorry fellas, most of the fellas might find it difficult for the concept, why this value is this, why this value is this, da 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 da, why this is this, why we need to differentiate this thing, why this point, why this should be equals to tan alpha. So that is why we always try to cover everything into one video tutorial. So that is why the video tutorial is really lengthy. So in addition to that, my language is really, sucks, and my handwriting is really slow. So overall, our video tutorial is really lengthy. I'm really sorry for that, fellas. So fellas, that's it for today. So if you have any question regarding this solution, please let me know in the comment section. So best of luck for your exam. Stay cool, stay awesome. Best of luck for your exam. And as always, peace with chemistry.